Okay, so this is problem 22.14 from homework 1, and the problem states 2 small plastic spheres each have a mass of 1 gram and a charge of negative 52 nanocoulombs. They are placed 3.0 centimeters apart, center to center, and for part A, they want us to figure out what is the magnitude of the electric force on each sphere. So I've drawn our plastic spheres here. The minus signs indicate that they're negatively charged, and since they're both negatively charged, they're going to be repelling each other. So I've drawn the arrows here because they're the force is going to be pushing away from each of them. And here's the R, which is 3.0 centimeters, and we know their mass is 1 gram, and the charge on both of those spheres is going to be negative 52 nanocoulombs. So in order to find the magnitude of the electric force, we can simply use Coulomb's law, which states that the force of 1 on 2 is equal to the force of 2 on 1, and that's going to be equal to our constant K times the absolute value of the first charge times the absolute value of the second charge, all divided by that R squared. And so for that, we can just plug in those numbers. So we have our force equal to our constant K, which is 9.0 times 10 to the 9 newtons times meter squared over coulomb squared, and our 52 times 10 to the negative 9, which is 52 nanocoulombs, and that's squared because there's 2 of them. And then we have our R, which I've converted here to meters because we know we need to cancel those out. So converted to meters, that's 0.03 meters squared, and that's all going to be equal to 2.7 times 10 to the negative 2 newtons. So that is the magnitude of our electric force on each sphere. And then for part B, they want us to find out by what factor is the electric force on a sphere larger than its weight. So for this one, we need to remember that weight is equal to the mass times the gravity. So watch out for that, because when I first did this problem, I actually just did the mass and came up with the wrong answer. We know weight includes the gravitational force as well. So we take our mass, which was given to us as 1 gram. We want to convert that to kilograms, so we can cancel. And that's going to be equal to 0.001 kilograms times our force of gravity, and we get 0.0098 kilograms times meters per second squared, which is just newtons. And then, so now to find that factor, by what factor the electric force on the sphere is larger than the weight, we need to take the electric force and divide that by the weight. So we had our electric force, we divide that by the weight we just calculated, and that factor is going to be 2.8. So its electric force is 2.8 times larger than its weight. And yeah, that all ties into what we're learning in chapter 22 with electric forces and Coulomb's law.